Open source AI is transforming the defense sector. Here to discuss its innovations are Molly Montgomery, Public Policy Director at Meta, and Donald Polaski, Vice President at Booz Allen Hamilton.
Thank you. Well, great to see all of you, and really excited to have this conversation about Space Llama, which we're really looking forward to hearing about. I'm Molly Montgomery, so I lead national security at Meta, and I'm really delighted to be here to have this conversation about AI in the space domain with Booz Allen Hamilton, Vice President for National Security, Don Polaski. As many of you know, the Trump administration has prioritized the rapid deployment of AI by the US government, including in defense and national security, part of why we're all here today, right? And the administration is also really focused on growing the Space Force's offensive capabilities, but also its deterrent capacity, and revitalizing human space exploration with missions to the moon and eventually to Mars. And so, given the limitations on connectivity and computing in space, the deployment of LLMs is really an obvious use case. And so, Booz Allen Hamilton is a leader in this space, and the company put the first LLM into space. We'll hear a little bit about that today, and in April announced, in collaboration with Meta, Space Llama, which it's deployed to the International Space Station. I also want to just point out that last night at the Washington AI Network's AI Honors, Booz Allen received the honor for space innovation. So we'll just start, Don, by congratulating you on that honor. Really terrific to see what Booz is doing in this space. And would just love to start by hearing a little bit more about Space Llama. What is it, and what are the challenges and the opportunities that led you to its development?
Yeah, that sounds great. And is my mic on? Can folks hear me? Is that better? Okay. Well, still good? Perfect. So Space Llama, yeah. So Don Polaski, Vice President of AI for our national security sector at Booz Allen. Better? All right. And so we'll talk a little bit about Space Llama. So Space Llama is a capability that we developed in partnership with Meta. And the mission scenario around Space Llama was really this. I don't know if any of you have ever trained to be an astronaut. Show of hands. I'm not seeing a lot in the room. I had not trained either.
Not me, definitely.
But I had the opportunity to learn about the process as we were working on this. And I'm a physicist, I'm a mathematician. Like generally I'm like kind of a smart guy. But when you think about what these astronauts have to go through, it's truly amazing, right? They're mathematicians, they're scientists, they're physicists, they're engineers. And the stack of things that they have to remember in order to keep the space station up and running, in order to respond if something goes wrong. I mean, I can't even do it with my hands, right? The stuff that is being stored in these folks' brains, it's just really off the charts. And so we were looking at this mission problem, and we were looking at large language models, and we thought to ourselves, okay, these models, just being able to ask a natural language question and being able to get the response that you need, that's a heck of a lot easier than flipping through thousands of pages of PDFs. That's a lot easier than having to memorize every single thing that could go wrong with every single nut and bolt on the space station. And so the mission scenario really kind of like, it was the perfect fit for large language model technology. But why Space Llama is a little bit different is because when you think about the compute resources required for large language models, it's massive, right? Like you need to have a ton of energy, you need to have GPUs typically, right? And you need to have the underlying compute infrastructure. Well, what's the one thing that they don't have, on the International Space Station? They don't have the cloud, right? They can't just spin up EC2 instances and deploy models that are as large as they would like. And so you really have to address this use case, you really have to think about how can we take this great open source model like that Meta has produced, and how do we fine tune it, and how do we re-architect it a little bit so that it can actually work on the hardware that's available on the International Space Station. And so that's really, kind of, I think, what Booz Allen brought to Space Llama, right? Meta provided this awesome model, Llama Vision 3.2, highly performant, And then our Booz Allen team really focused on, okay, how do we actually make this thing so that it could run on the space station? And so I think, thinking about the metrics, I think Llama out of the box, it's like you need like 1 kilowatt of energy to run it. It's a pretty large model in terms of like how much storage space you need as well. And so we were able to go from that 1 kilowatt down to 20 watts, right? Which is like an order of magnitude change. And that's really what allowed us to deploy that model into that environment. And so that was really, I think, the engineering expertise that Booz Allen brought, and coupled with that kind of like open source model that Meta provided, we were able to solve this pretty pressing missing challenge. And it's been a very successful collaboration so far.
Terrific. Well, thanks, Don. And I think this is one of the themes, certainly, that we're seeing, particularly in the national security space, but more broadly, which is taking models, quantizing them, and pushing them out to the edge. Obviously, space is a more extreme version of that, but this is something that I think is a theme that we'll see more broadly, and that as folks talk about the frontier, there's a lot of focus on the largest models and the most capable models, not necessarily on the models that are going to actually be the most useful for use cases, whether that is in space, whether that's the warfighter, whether it is a repair person repairing an aircraft or other technology. Certainly small models at the edge is a theme that we're looking a lot at. But I would love to just dig in a little bit more to the open source element of this. And if you could talk a little bit about, why did you choose Llama and what were the unique advantages of open source?
Yeah, so as we think about open source for this use case, as we think about it more broadly for national security use cases, for other federal use cases, the transparency of open source, the availability of open source, these are two of the key, I think, aspects that really drew Booz Allen to look at Llama as the exact right tool for this. I think as we think about this, as we think about how AI and how large language models, and generative AI in particular, the impact that that's going to have on the world around us, explainability is going to become so important. If we can't explain why a model made a decision, if we can't, break open that black box and understand what's actually going on inside, I think it introduces an amazing amount of risk, right? Both to the end users, to the companies that are using those technologies. If you don't know how a model was built, if you don't know if you aren't able to see the weights, I think it just it creates an opportunity for ambiguity and misunderstanding about how that model can perform. I think about kind of like spending in AI, kind of across globally, right? I think China has committed to spending billions and billions and billions of dollars, right, to try to catch up to the United States in the AI race. As someone that's involved in national security, that scares me, right? Because I think the federal government is making our federal government is making leaps and bounds in investing in AI, but the numbers that China is talking about, they're pretty scary. But when you start to look at the investment that U.S.-based commercial companies are making in building out this technology, if you look at U.S. federal spending plus the spending from companies like Meta and the other large language model providers, it's going to trump what we're seeing from China. And so I think that's the other aspect of open source as well. You guys have built this capability. You've put so much time, so much money, so much investment in it. And all we have to do is go and grab it off the shelf, fine-tune it a little bit, but we don't have to spend that same amount of money to build a brand new model for the federal government. The models are already there. Let's use them. That's really our competitive advantage, and I think why open source is so important. I just think a model where a company is like going into a cave and building something in secret, and they say, look, this is going to be the next greatest thing. The trustworthiness isn't there, and I think the viability of those kinds of approaches just is not as viable as open source.
Yeah, well, certainly, obviously it's something that Meta has invested in and has been part of our approach from day one, and really is in the DNA of the company, but also something that I think we've seen, as you say, with Chinese competitors, that we're likely to see the same type of trends that we've seen with other technologies like Linux, like Android, for example, where sometimes, a lot of us probably use iPhones, but sometimes we forget that 70+% of the world's handsets actually run on Android, which is open source. And I think to your point, we should all be glad that those are American, or that Android is an American, a Google product rather than a Huawei product. And so I think certainly that's important. And the other thing I would just mention is obviously the explainability is critical, as you said. Portability, obviously, to be able to put this onto the space station. In that case, it's connectivity that is really, the issue, and that's going to be the case in other austere environments, certainly. But as well, the security aspect in terms of not having to make API calls back to a cloud, I think is something that we see as really critical as we partner with governments, partner with companies in that are working with the USG in the national security space, defense industrial base, et cetera. So that I think is critical as well.
And Molly, if you don't mind me jumping in there, that disconnected piece, we can't lose sight of that, right? With the Space Llama example, there's no way for that model to phone home back to Earth, right? You can't make a call back to something that's living on the cloud. The latency wouldn't, isn't there, and just the basic connection, right? It wouldn't work, half the time because of where the space station was positioned, right? And so as we think about national security use cases in particular, a lot of these networks, right, that these models are going to be the most helpful to be deployed to, they're in DDIL environments, right, so like degraded connectivity. They're in highly classified network environments, so no connection to the outside internet. And so being able to have that portability, right, something you could like throw into a container and migrate into these networks that don't have that connection to the internet. If you don't have that capability, you can't even start on the most interesting use cases. And so I just wanted to kind of foot stomp that connectivity piece and being able to work in those disconnected environments or those environments that have intermittent connectivity. That is really going to drive the most compelling use cases and also help to address these scenarios that are of particular interest for national security.
Yeah, absolutely. And I think particularly as we see more and more deployment, I think we're going to hear the word latency a lot more, right? And this is something where, if you're actually, if you have these models on-prem, you don't need to worry about that, nearly as much, even if you're not in space or another very, very austere environment. But you mentioned a little bit the U.S.-China competition, aspect of this, and I think that's something that's critically important. SCSP certainly, has been a leader in highlighting that for a number of years with respect to AI. And, obviously we've seen a lot of conversation around open source and discussion about, the role that it plays in national security and, sort of this risk-benefit or risk-opportunity equation. And I mentioned DeepSeek once already, and certainly I think I heard Representative Molinar a few minutes ago talking about a Sputnik moment. I think DeepSeek was certainly a Sputnik moment for a lot of folks here in Washington about AI. But I think, as we look at the U.S.-China competition elements of this, and as we also look at wanting to deploy these models in ways that are safe and are secure, would love to just talk a little bit about the regulatory environment and how we ensure that we have really the right balance to support open source initiatives while ensuring that safety, security, and accountability. Since obviously these projects are by nature collaborative, community driven, and so would love your perspective on that.
Yeah, and I think there are kind of two tracks to take the question around regulatory issues down. I'll start around that open source piece first, right? And one of the things that one of the things that keeps me up at night is that I know that we have countries that we're in competition with, and China, others, Russia, investing heavily in these technologies. And so one of my biggest fears is that the capabilities that they are building start to get adopted by our friends because we are not able to, from a regulatory perspective, find a way to get our technology into their hands in a way that we feel is safe and secure and repeatable. Because I think every country in the world, if they don't have an AI strategy, they're at significant risk, right, as we think about the next 3 decades. And so finding ways for the administration, for the current administration, future administrations, to partner with commercial industry to take these technologies and find a way to get them into the hands of our allies, whether that's NATO, whether that's Five Eyes, so that we can make sure that when those countries are looking to upgrade their AI capabilities, they're coming to the United States as one of their closest allies, and we are reliable, and we can provide that technology to them. That is how we kind of continue, I think, to maintain our AI dominance. And I think that is just so important from a national security perspective. And then on the flip side, I think the other piece that open source plays into this is that explainability piece. I think NIST, actually, the Commerce Secretary was at the AI event last night, and he was making some great announcements about some upcoming changes at NIST, which I won't go into here today, but keep an eye out if nothing was published on that yet. But at the end of the day, I think with the new administration, there's a pivot towards how do we have responsible AI, but how do we do that without slowing down the progress of innovation? And so I think open source is a key to that, because it allows you to really understand the risks associated with the models, understand how the models were built, ensure that they were trained in a responsible way and vet them and be able to get the access that you need to really understand how the models will perform, but in a way that will not slow down the pace of innovation. Right? When you have an open source program and you could actually see every single code commit, right, and who is committing that code, and know explicitly, these are the 100 people, right, that made the commits in the last 10 days, and trace back, like, okay, who are these people, right? Are they U.S. citizens? Are they coming from different parts of the world? I think just having that information and open source allowing you to get information in that way, I think that is also going to be a huge part of the regulatory picture.
Yeah, well, and this is the reason, right, why in terms of encryption, open source has been the standard and preferred by the U.S. government and many other governments for a long time. I think it's taken us a little while to sort of remember that and to apply those lessons to open source AI. But certainly in this administration, I think there are a lot of folks who come from the tech world, lived the crypto wars, let's say, and have that experience. I want to highlight a couple of the things you talked about. I mean, certainly, as we think about AI, and other folks have made this point, it's, when we look at previous technologies, government was critical in terms of actually, that R&D spend in terms of driving that innovation, whereas this is a set of technologies that really are being driven from the private sector. And so I think will require a little bit of a different model in terms of public-private collaboration to figure out, as you say, what is the right balance in terms of safety, security, accountability, but also ensuring that we're not really tying one arm behind our backs in terms of innovation. And obviously, that's critical in terms of our own ability to achieve AI dominance. It's critical in terms of the deployments that we know that this administration and our allies as well are looking to make quickly to lead in this space. So really, really, I think an important set of points there. I do want to talk a little bit about the future, and going back to again this theme of geopolitical competition. I saw that yesterday Roscosmos announced that they are themselves planning on putting GigaChat, their homegrown model, onto the International Space Station. So again, an illustration that the space domain is also fertile ground for geopolitical competition. But as you hear that, as you look at how Space Llama is performing in space, would love to hear a little bit about, what do you see in the future? How do you see that developing, both in terms of Space Llama itself, but also the domain overall?
I'm smiling to myself a little bit, because the first thing that popped into my mind was to say, well, the sky's the limit when it comes to generative AI in space. And what I mean by that is, like, if we look at the history of the space race, going back to the Soviet Union, there were some watershed moments, right? We all remember, we talked about Sputnik moments earlier. We were the first on the moon, right? Like, there's going to be a back and forth. And that's okay, right? Because that is going to push these, our countries to really continue to invest in these technologies to ensure that in this space domain, which is becoming more and more important, I think, over the next 10 years, that we continue to maintain that edge. And so Space Llama, getting it onto the space station, we're happy and excited to help those astronauts, right, with those 10,000 pages of PDFs. But as we think about the next step with this technology, we start to think about space situational awareness. How are we tracking what's in space? How are we responding to those things, right? If you have a catastrophic event where a satellite is hit by another satellite and is starting a cascade, if you're a person on the ground, you're going to be looking up and there's nothing that you can do. But if you start to think how a network of satellites that have large language model or generative AI technology deployed onto them can start to react to those events in near real time without those latency issues, without those data downlink issues, you're starting to I think, envision a view of space that is fundamentally different from what we've had today, because it's smarter, because those assets can start to think on their own, because they're not just hurtling around the Earth, following the laws of gravity and paying attention to the geodetic. Now they're actually starting to be thinking systems. And so, that's just one example, right, of as we're starting to get these constellations up, as we're starting to get more compute into space, as we're starting to have to react, I think, more readily to the space domain, I think that we'll see a proliferation of generative AI technology, kind of across those various platforms. The other thing that I want to add, though, is that this is not limited to space, right? So it is Space Llama. The model was fine-tuned for this particular use case. But the techniques used to fine-tune it, the techniques used to get it to fit onto that compute that's on board the space station, that is applicable to wearables, right? So you can imagine a future where you've got, Olympic athletes, with a bunch of sensors going through their workout, and all of that data is being fed into a large language model. It's being processed, and they're getting feedback in near real time, right? That's highly tuned to their own physiology, highly tuned to their own biometric signature at any given time. That's a sports-based use case, right? But imagine being able to do that with our warfighters, right? Who, being able to monitor those things that they just cannot monitor on their own, right? It's great to have something attached to you that will tell you your heart rate, but when you're in the middle of a battle, it's like that's not that's data. Right? What you need is information, and that's what I think these models that are really fine-tuned and really tailored for these DDIL environments will be able to get you. We could just sit here and name examples all day. Drones, right? Another, I think, if we look at Ukraine and we look at Russia, if you've read the news in the last 2 weeks, right? I think you've started to see, if you hadn't been tracking already, the importance of drones, right, in this next generation of warfare. And there are going to, same thing, arms race, right? We're going to build drones. They're going to build drone jamming technology, right? It's like, okay, so if you have a network of drones, but they can't get back to the home base, they've got to be able to act autonomously in some way. And again, that's an area where I think generative AI, especially tuned, for the individual form factors, is going to have make a lot of progress in the very near future. So those are just some examples that we could talk about.
Yeah, I mean, that's terrific. And I think obviously Meta, we've invested, I won't count how many billions of dollars in wearables and the technology that goes behind them. And it's something that we're thinking about a lot as well, and taking steps in this space. And I think that is an area as we look to combine these technologies that we have already developed into new form factors, and as you say, look to harness the data that already exists. And obviously companies like Booz and the U.S. government have that in spades, but how do we make sure that we're actually incorporating that effectively, fine-tuning these models for these specific purposes, and then pushing them out to the edge where they can really make a difference. One of the things that we think a lot about and that our engineers always love is feedback. You put these models out into space because they're open source. You don't always know how they're being used, and you don't always get the feedback. So, would love to take the opportunity to just ask a little bit with a couple of minutes left, if you have any kind of learnings from this process that you can share that might benefit not just Meta and our engineers, but also others out here who are looking to do their own development of small models at the edge or other types of projects that you all are undertaking.
Yeah, of course. So if I had to give any initial feedback, it'd be 2 thumbs up, right? I would hit the like button. It's very easy to use out of the box, right? Booz Allen, I think we started playing around with Llama as soon as the earlier versions of Llama as soon as it was released. And in terms of being an open source model that you're able to easily deploy into these air-gapped environments, one of, if not the standard, right, for performance and ease of integration. In terms of lessons learned, with these technologies, when you go from that 1 kilowatt down to 20 watts, when you go from and get a little technical, 30-bit technical precision down to 4-bit technical precision, right? That is, you have to do that in order to be able to deploy, to get the memory footprint down to 6 gigabytes. You have to be able to do that, but you don't just go in and click the button and then you're like, okay, this is going to work perfectly. There's still engineering and scientific rigor that you have to bring to the process. And so I think what Llama really allows you to do is, as you're making these decisions, it's easy to implement them, and then you just have to go back and check to say, okay, is this level of performance going to be sufficient for my use case? And so what we found when we were building Space Llama was that by taking this approach to kind of reduce the size of the model, while simultaneously incorporating fine tuning, we were actually able to increase performance for this very specific set of tasks. And so, like any engineering, you're going to have a set of levers, and you're going to have to pull those levers to optimize around cost, optimize around performance, optimize around latency. But the good news is that Llama makes that side of it, very easy, right? Because you not only is it open source, but you could hop on Stack Overflow and see what other people are doing with it, and you've got other people in the federal government space or across other teams at Booz Allen that have those lessons learned. Whereas, again, going back to these black box models, you might not have that flexibility to be able to make those changes at the level that you need to for these specific deployment environments. So I think that's what I'd want to leave the audience with in terms of recommendations. Is there, as you guys are starting to do this on your own.
Yeah, absolutely. And I think, one of the things that we hear is certainly that there can be a little bit more upfront effort, let's say, but then the ability to do all of that customization is something that is really critical in terms of getting the performance that you actually want, for a particular use case. And it is, I think, really exciting that we are still only at the beginning of this journey in terms of seeing what developers can do and how that innovation can build on itself as folks, learn how to squeeze, the most performance and the most customization out of these models, even, as we see with Space Llama at, very small sizes in terms of compute. I want to give you an opportunity, if there's anything we haven't covered so far, to just leave a final word. Anything else you'd like to cover?
Yeah, of course, Molly. So I'll keep it short and sweet. But the reason that I'm here today, and so excited to be chatting with Molly from Meta is that I'm super passionate about this technology, right? I think probably that's the reason that most of us are here today. Maybe there are some naysayers in the audience who are like, oh, we're going to, AI is going to slip up at this conference. I just know it. But the only way we're going to make the progress that we need to in order to continue to live in the world that I think we all want to live in is by having our brightest minds focused on these problems, using the best tools, using the best technologies, right, that are really the most efficient for driving progress. And so I'm hopeful that everyone here has learned something today, from this talk and more broadly from the conference. And I really hope that if you're not an AI practitioner already, you start to develop those skills. If you've got a great idea for how AI can be used for a particular use case, start advocating for that. Because I think at the end of the day, what the world looks like now, it's going to look very different 5 years from now. And I truly believe, and this is somebody else's quote, it's not mine, but in order to predict the future, like the easiest way to do that is to create the future, right? And so that's the power that all of us have today, and we just got to dig in and start doing it. So it couldn't be a more exciting time for this technology, and super excited that we got to partner with Meta on this.
Yeah, absolutely. Well, I couldn't have said it better myself, but really I think that your words and the promise of Space Llama to the moon and back really illustrates the potential for this technology and encourages us all to put our imagination and our skills to use as we think about how we can use it to support our national security, support innovation, and prosperity. So thanks so much, Don. Appreciate the time. Thanks to all of you for being here.
Thank you to the audience.
All right.